whereas technology can produce speeds that are at least 1 to 2 orders of magnitude larger than that.
On November 30th, 2025, the Hubble Space Telescope captured something that doesn't belong here, a rogue interstellar comet hurtling through our solar system at impossible speeds. And scientists say it's behaving unlike anything they've ever seen before. This is 3I Atlas, officially designated C/2025 N1, and it is only the third confirmed interstellar object ever detected passing through our cosmic neighborhood. Unlike comets born within our solar system, this visitor originated from beyond, arriving from the direction of Sagittarius, traveling at a blistering 58 kilometers per second. That's over 130,000 miles per hour. It was discovered on July 1st, 2025, by NASA's Atlas Survey Telescope in Chile. And what it's doing here is raising serious questions among the world's top astronomers. This isn't a drill. This isn't speculation. This is happening right now, 178 million miles from Earth, and the implications are staggering. Let's break down exactly what we know and what makes this discovery so unprecedented. First, the discovery itself. On July 1st, 2025, NASA's Atlas Survey System, a telescope network designed to detect potentially hazardous asteroids, picked up an anomaly in the night sky over Rio Hurtado, Chile. The object was designated 3I, a TLAS, also known as C/2025 N1, and cataloged under the identifier A11PL3Z. At the time of the detection, it was already 4.51 astronomical units from the Sun, that's about 418 million miles, and moving with an orbital eccentricity of 6.13. For context, anything with an eccentricity above 1.0 is on an escape trajectory. It's not bound by our Sun's gravity. An eccentricity of 6.13 means this object is moving so fast that nothing in our solar system could have launched it. It came from interstellar space, and it's going back. Second, the trajectory. 3I Atlas didn't just pass by, it carved a path directly through the inner solar system. On October 3rd, 2025, it made a close approach to Mars, coming within just 0.194 astronomical units, roughly 18 million miles. That's closer than some of our own spacecraft have traveled. Then on October 30th, it reached perihelion, the closest point to the Sun, before beginning its outbound journey, and it's not done yet. On March 16th, 2026, 3I Atlas will approach Jupiter at a distance of just 0.357 astronomical units, approximately 33 million miles from the gas giant. Third, the speed. This object is moving at a radial velocity of 58 kilometers per second, over 36 miles per second. To put that in perspective, that's nearly 200 times faster than a commercial jetliner. That kind of velocity doesn't happen by accident. It's the signature of an object that has been traveling through the void of interstellar space for potentially millions of years. Fourth, the observation campaign. NASA didn't just spot this object and move on. Hubble observed it immediately after discovery in July, and again on November 30th, using its Wide Field Camera 3 instrument. The telescope tracked the comet as it moved across the sky, resulting in background stars appearing as streaks of light, a visual testament to the object's incredible speed. Multiple NASA missions have since studied the comet, and observations are expected to continue for several more months as it exits our solar system. Now here's where it gets truly unsettling. The new Hubble image reveals something deeply unusual, a teardrop-shaped glowing halo extending toward the Sun, with what astronomers are calling an anti-tail. Most comets have tails that point away from the Sun, blown back by solar wind and radiation pressure. But 3I Atlas is displaying a structure that extends toward the Sun, an anti-tail reaching approximately 60,000 kilometers, or 37,282 miles, into space. This isn't normal comet behavior. Harvard University professor Avi Loeb, a leading astrophysicist known for his work on interstellar objects, has gone on record with a striking analysis. According to Professor Loeb, the teardrop shape of the coma in post-perihelion images is associated with a large number of macroscopic, non-volatile objects that have separated from the comet due to a measured non-gravitational acceleration away from the Sun. Let that sink in. Non-gravitational acceleration, that means something is pushing this object, or parts of it, in ways that gravity alone cannot explain. Professor Loeb predicted that by November 30th, the swarm of objects would be closer to the Sun than the main body of 3I a TLAS by approximately 60,000 kilometers. The new Hubble image confirms this prediction with what he describes as perfect agreement. The anti-tail extension matches his calculations exactly. So what does that mean? It means that 3I Atlas isn't just a comet, it's shedding material, or possibly fragments, in a way that defies conventional models. The glow around the nucleus spans roughly 40,000 kilometers, 24,855 miles, and the structure is evolving in real time as scientists watch. This raises a critical question. What is 3I Atlas made of? And why is it behaving this way? According to astronomers tracking the object, interstellar comets like 3I Atlas provide a rare window into the composition and conditions of planetary systems beyond our own. These objects formed around distant stars, potentially billions of miles away, and carry with them the chemical and physical signatures of their home systems. Investigators warn that the non-gravitational forces acting on 3IATLAS suggest the presence of volatile ices or possibly a fragmented internal structure that is reacting to solar heating in unexpected ways. The fact that this object is shedding material at such distances while moving at extreme velocities indicates it may be compositionally distinct from comets native to our solar system. Officials from NASA and the European Space Agency emphasize that continued observation is critical. Every data point collected from 3IATLAS adds to our understanding of what exists in the interstellar medium, the vast, largely unexplored space between stars. And with only 3 interstellar objects ever confirmed, each one is a scientific treasure trove. But here's what makes this discovery even more urgent. The first interstellar object, 1I/Oumuamua, detected in 2017, exhibited anomalous acceleration that scientists still cannot fully explain. The second, 2I/Borisov, discovered in 2019, appeared more comet-like, but still raised questions about interstellar chemistry. Now 3I Atlas is showing behaviors that echo Oumuamua's mysteries, non-gravitational forces, unusual morphology, and a trajectory that defies easy categorization. Are we seeing a pattern, or are we simply witnessing how little we truly understand about what travels between the stars? Here's the moment where the stakes escalate. The anti-tail structure observed in 3I Atlas isn't just scientifically interesting. It's a direct indication that this object is actively changing as it moves through our solar system. The teardrop shape, the separation of material, the non-gravitational acceleration, these are all signs of dynamic processes occurring in real time, 178 million miles from Earth. Professor Loeb's prediction, confirmed by Hubble's November 30th observation, means that scientists are now able to model and predict the behavior of interstellar objects with increasing accuracy. But it also means that 3I Atlas is not a static, inert rock flying through space. It's shedding, it's accelerating, it's evolving, and it's doing this as it approaches Jupiter, the most massive planet in our solar system. On March 16th, 2026, 3I Atlas will pass within 33 million miles of the gas giant. Jupiter's immense gravitational field will interact with the comet, potentially altering its trajectory even further or causing additional fragmentation. What happens during that flyby could provide critical insights or raise even more questions. But there's something even more alarming buried in the data. The eccentricity of 6.13 and the radial velocity of 58 kilometers per second mean that 3IATLAS is on a one-way ticket out of the solar system. Once it passes Jupiter, it will continue accelerating outward, eventually leaving the sun's gravitational influence entirely. Within a few years, it will be back in interstellar space, traveling through the void for potentially another million years before encountering another star system. Which raises the question, how many objects like this are out there? How many have passed through our solar system undetected? And how many more are on their way? NASA estimates that interstellar objects may pass through the inner solar system several times per year, but most go unnoticed because they're small, fast, and dark. Atlas detected 3I Atlas only because it developed a visible coma, a glowing cloud of gas and dust as it heated up near the sun. Without that glow, it would have slipped past us completely. That means we're essentially blind to most of what's passing through our cosmic backyard. So what does this mean going forward? First, it confirms that our solar system is not isolated. We exist in a galaxy filled with rogue planets, orphaned comets, and ejected debris from distant star systems. These objects are constantly moving through interstellar space, and occasionally they cross paths with us. 3I Atlas is proof that we are part of a much larger, more chaotic cosmic environment than we often acknowledge. Second, the behavior of 3I Atlas, particularly the non-gravitational acceleration and anti-tail structure, suggests that interstellar objects may be far more complex than previously assumed. They're not just frozen relics, they're active, dynamic, and potentially harboring materials or processes we've never encountered before. Third, the fact that Professor Loeb's predictions were confirmed with such precision indicates that scientists are getting better at understanding these visitors. But it also highlights how much we still don't know. Every new interstellar object brings surprises. Every observation challenges existing models, and every close approach offers a fleeting opportunity to study something that originated light years away. The window of observation for 3I Atlas is closing. As it heads outward, past Jupiter, and toward the edge of the solar system, it will grow fainter and harder to track. Within months, it will be too distant for even Hubble to observe clearly. And then it will vanish back into the interstellar void, carrying its secrets with it. But here's what we can't ignore. The discovery rate of interstellar objects is increasing. Oumuamua in 2017, Borisov in 2019, Atlas in 2025. That's 3 in 8 years. As detection systems improve and more survey telescopes come online, we're likely to find more, perhaps many more. And each one will force us to confront the reality that space is far stranger and far more crowded than we ever imagined. The next interstellar visitor could be detected tomorrow. It could be larger. It could be faster. It could pass even closer to Earth. And we need to be ready because 3I Atlas isn't just a scientific curiosity. It's a warning, a reminder that we live in a universe that doesn't care about our boundaries, our understanding, or our sense of safety. Objects from beyond are passing through, and we're only just beginning to notice. The truth is out there, literally hurtling through space at 130,000 miles per hour, and it's not slowing down. Subscribe for more updates as the truth continues to unfold.